Welcome back. In this video, we're going to have a look at how we can factorize trinomial expressions. What is a trinomial? Well, it's simply an expression where you've got a squared value with a linear value plus a constant. Now, the reason this is powerful is when you're doing Year 10 mathematics, when you're working with parabolas and quadratics, the factorization technique allows you to graph these easily. Now, similarly, if you're trying to work out equations, for example, and you've got a trinomial expression, if you've got an x squared plus a linear term here, it's most of the time it's not possible to get x equals something. So again, you'll have to go into a factorization form to be able to solve these guys. Right, now the process of factorizing these isn't quite as straightforward as the last video when we were looking at single term factorization. In this case, we have to do a little bit of deductive reasoning. So we've got this x squared plus 12x plus 27. The way in which we factorize it is we're going to get something that looks of the form x plus a number, and we'll call it alpha, times x plus a number, and we'll call it beta, like so. And if we look at this, we have to ask ourselves, well, when we're working, or if we expanded this out, what we'd find is that we're getting an x times alpha plus an alpha times x. So based on that, this term in here, the 12x, this is a case of alpha plus beta, and then for the 27 we're getting an alpha times a beta, so that will be alpha times beta. So looking at this pattern here, what we can see is that to get the factors of this particular expression, we have to look at what adds together to give a value of 12 and what multiplies together to give a value of 27. Now, the most straightforward way to look at this is you say, well, what are the factors of 27 here? And the factors of 27, are simply going to be 3 times 9. Now, looking at the middle term here, the 12x, we're looking at what two numbers can add together to give 12x. And those numbers are 3 plus 9. So 3 plus 9 is 12. So expanding this out, we're going to get x squared plus 9x plus 3x plus 27. Alright, looks like I made it worse, but trust me, I didn't. Our next step is we need to look at the common factors between this x squared plus 9x and then this 3x plus 27. Now factorizing these, we get x, then we've got an x plus 9. And then for the second one, we've got the 3x plus 27. So we can take out a 3, then leave behind an x, and then leave behind a 9, like so. Alright, now I'm going to get rid of this to free up a little bit of space, and I'll get rid of that as well. Cool. Now, next step is, look at what's common here. We've got an x times an x plus 9 and a plus a 3 times an x plus 9. What we see is these two guys here, they're both common. So what that implies is we can pull out this x plus 9, like so. And then what we leave behind is this x plus 3. And therefore, we're in this factorized form where our factors are x plus 9 times x plus 3. So we've thus factorized a trinomial expression. So a little bit complicated, but nothing we can't handle. Alright, looking over to question 2, we've got x squared plus 5x plus 6. So remember, we have to ask ourselves, what are the factors? And if we think the factors of 6 are going to be 2 times 3. Now, what do these add together to give? Well, they add together to give 5. So what we're going to do is we're going to go x squared plus and we'll go 2x plus 3x plus 6. Will that work? Alright, that one's not going to work, so we've got to change it slightly. Rather than the 3 and the 2 there, we'll swap it around. We'll go 3 here and a 2 here. And I'll explain. Reason for this is when we're trying to factorize, what we want to get is 2 common terms in the brackets as seen over here. So by putting the 3x next to the x squared and the 2x next to the 6, if we take out a common 2 between this 2x and plus 6, and we're going to leave behind a common x plus 3. So doing that, we'll take out an x over here, x plus 3. Then we'll take out the common 2, the x plus 3. And then, lo and behold, we've got this constant x plus 3 here. And therefore, we're left with x plus 3. Then x plus 2 is what we leave behind. And therefore, we've factorized this trinomial. So, not too bad. Alright, moving on to question 3. This is where it gets a little bit trickier, but not too much trickier. We've got x squared plus 2x minus 15. Looking at that, we haven't encountered a minus before, but again, it's nothing we can't handle. We simply ask ourselves, what are the factors of 15? And the factors are going to be 3 times 5. Now, we've got a negative here, so this means that there's more factors for the minus 15. We can get a minus 3, or we could get a 3 times minus 5. Now, look at the 2 here. What are the 2 factors that add together to give a positive 2? And the answer to that is we're going to get 5, actually minus 3 plus 5. So this guy over here. So therefore, the factors we're looking at are minus 3 plus 5. So we're going to go x squared plus, or I should say minus 3x plus 5x minus 15. Factorizing, we're going to pull out an x, leave behind an x and a 3, plus, and we'll take out the 5, leave behind the x minus the 3, and then we can simply grab the x, take 3, multiplied by x plus 5. So nothing to it, just looks a little bit trickier because of the minus. Alright, example 4, notice again, we're not dealing with just one minus now, but rather we're contending with 2. But again, follow the same process. You ask yourself, what are the factors of 35? And that one's a nice simple one. It's simply 5 times 7. Now notice it's a negative, so it could be negative 5, or it could be negative, or 5 times negative 7. But the question is, what 2 numbers add together to give minus 2? And that's definitely going to be 5 take 7, like so. Alright, now we've got our 2 factors. We write x squared minus, and in this case, we will go positive 5x minus 7x minus 35. Now, simplifying that, we'll take out the common x, leave behind an x plus 5, and then notice over here we've got a minus 7x minus 35. In this case, we're going to take out a common minus 7, leaving behind an x plus a 5. Now we've got a common x plus 5. We're going to write x plus 5 multiplied by x take 7. And therefore we have factorized our trinomial over on the left here. So once again, we find that it is nothing we cannot do. So this has been a short video on how to do trinomial factorization. It's a really powerful tool to be able to use. You don't necessarily need to know how to do it in year 9, but the sooner you learn how to do it, the easier it's going to become in the future, because you definitely see this in year 10. And when you're doing year 11 methods, you'll use this in probably every second, every third question. So it's just a really great tool to know how to use.